So in this chapter, we are going to talk about linear regression. We are also going to talk about the line of best fit and also learn how to interpret the coefficients of the line of best fit. And then also know the assumptions for linear regression. And then when we talk about the assumptions, I have some examples in the textbook that we'll try to answer. So let's start with the line of best fit. So a good line is a line that best well fits the data and then have small residuals. So I'll be explaining what residuals are when we get to the graph. The line of best fit is the line which the sum of squared of the residuals is the smallest. And this idea is what we call the least square line. So when we look at this graph here, the first one, as you already know, is a scatter plot. So now I want to ask, how do we fit the line of best fit? Remember, it is the line with the smallest sum of squared residuals. So for example, if I decide to draw this line here, do you think this line here is the line of best fit? Why? Okay. Anybody else? And also remember, we are talking about a line where the residuals are very small, as much as we can. Is that okay? How do we get the residuals? So I'm going to explain that to you. Remember, these things you see in blue here are your observed data you were given. We've already learned how to draw scatter plots. So the residual is the distance, the vertical distance from the point to the line of best fit. For example, the distance from here to the distance between, let me clean this one, it's too big so you guys can see it well. The distance between this point here to this side is the residual. Is that okay? The distance between this point here to the line of best fit is the residual. Can you see that? So that is the residual. And so we will denote that by E, or usually you see like something like this, like usually denoted by. Is that okay? And it's giving us the observed minus the predicted. So residual. What is the predicted? The predicted is the what? What is on the what? The line of best fits. Is that okay? And so when you look at this line here, you can see that the residuals are what? Very big. Look at this one from here to here. Is that okay? Which means that we can do better. Does that make sense? And so this one here is a line of best fit. Is that okay? You cannot get a perfect line that is going to pass through all the points. Then that is not going to be a line. It's going to be, does that make sense? So we are just trying to draw a straight line as much as possible so that the distance between these two here is very small as much as we can. You see, some will be very small, some will be a bit large. Is that okay? But we know at least this is better than this one. Is that okay? So that is what the line of best fit means. So in your homework, they're also going to ask you. So here we are trying to what? Minimize the sum of squared of the residuals. I've already explained to you what the residuals are. The residuals are this. The vertical distance between the observed and then the predicted. Is that okay? This is the what? Residual for this point. Residual here. Residual here. Is that okay? So that is the residual. And so there are certain terms you need to know. So we call the estimate from the model. So for example, whatever the model predicts is what we call the what? The predicted value. Is that okay? How many of you have seen this equation before? If yes, you tell me what equation it is. So what equation is this? Mhm. Slope line. What did you say? Okay. Anybody else? So this is the slope intercept. Is that okay? The M is the slope, the B is the intercept. Is that okay? You've already seen this in high school. It is the same thing we are coming to do here. Is that okay? Except that we are not going to use the same variables. We are going to use different variables. So for us, we are going to use this guy here. Is that okay? So you can see the B naught is the B here. Is that okay? So the B naught is the what? The intercept. Is that okay? Where the line cuts the vertical axis. So for example, if I stretch this guy here, here is the what? Is the B naught. Is that okay? Where the what? The line cuts the vertical axis. So, and then this guy here is the slope. Is that okay? This is the intercept. This is the slope. Is that okay? Good. And then your data set is the what? The observed values. We've already talked about that in chapter 6. And then know that your error is the observed value minus the predicted. Okay? So that I want to ask you a question. If we have an error to be positive, what does that mean? So let's say that our error is what? Positive. It could be positive 0.1, 0.2, 1, 2, 3. What does that mean? Does it mean that our model under predicted or over predicted? How many of you think it's under predicted? How many of you think it's over predicted? You want to try? Want to try? Just feel free. This error here is observed minus predicted. Is that okay? And we don't know the values. But I'm just saying, if we find a difference between this and we are getting a positive number, what does it mean? Does it mean that the model over predicted or under predicted? Remember, this is the predicted value here. He's saying under predicted. Do you guys agree with him? What can we do to get positive here? It means that this guy has to be what? Bigger than this. Is that okay? Because they are subtracting. So for example, if you have like 3 minus 2, you are going to get a positive number. So it means that our model what? Under predicted. So if error is positive, it means the model what? Under predicted. If the error is negative, it means what? It over what? Predicted. Does that make sense? These are things on your quizzes and your homework. So it's good that you understand them. Is that okay? Good. So now that we have this foundation, we are going to now talk about how to estimate the coefficients of the regression line. So remember, the line of best fit, the idea is what? Is what we are trying to what? We get the least square by what? Minimizing the sum of squared residuals. There is a homework problem on this. So the least square idea is trying to what? Minimize the sum of square residuals, which is what? Mathematically, we are trying to minimize it. This is the residuals. Is that okay? And then this is the residuals. We are trying to minimize the sum. The residuals is also denoted by EI. You can see from here. I wrote that here already. This is the residuals here. And then, so you should have the idea that we are trying to what, minimize the sum of square residuals. The mathematics behind that, it's not for your consumption at this stage. Is that okay? But what you need to know is that beta 1 is given as this, and then beta naught is given as this. So I will entreat you to write those two formulas on your sheet that you'll be using to write your exams. So you need to have these two formulas on there. Is that okay? Beta naught is given as this, and then beta 1 is given as this, and then beta naught is given as this. We would also be interpreting what the slope means with regards to our data set, and also what the intercept means with regards to our data set. But for now, I want you to also take note of this. If you can also write this on your sheet, it's going to be very helpful. Is that okay? And then we will be applying that to our data set. And then we'll use this as a foundation to interpret the beta naught and then the beta 1 in our data set. Now that you have been able to write the slope formula and the beta naught formula, let's try to fill out this table. I took this table from one of your homework problems. So let's try to fill it out. We are asked to fill in the missing information. And we have A, B, C, and D. When we look at A, this guy is missing. Can you all see that? B, the same thing is missing. Is that okay? So what is missing here? It means that we have to be able to what? Write the model. Is that okay? So to write the model, we need to find beta naught and beta 1. Is that okay? To be able to fill here and then here. So let's do one after the other. So let's do A first. Let's write the beta naught formula. Beta naught is given as y bar minus beta 1 x bar. Okay? And then beta 1 is given as r sy divided by sx. The formula is here. That's why I told you that you should write that down. Okay, looking at this information here. For A, we have x bar to be 19. So first, let's try to find beta naught from, let's try to find beta 1 first, because beta naught, we need beta 1 to find that. Is that okay? So let's find beta 1 from A. Beta 1, we need R. What is R here? 0.9. Can you see that? So I put in 0.9 here. What is SY? SY is what? 9.7. What is SX? XX is what? 6.6. Okay. Now, when you use your calculator, what do you get for beta 1? So all you need to do is to do 9.7 divided by 6.6. And then you multiply that answer by 0.9. When I did that, I got 1.3227. Can somebody also confirm whether they got the same thing? Okay, good. Now let's find beta naught. Beta naught is what? Y bar. Let's do Y bar. Y bar here is 19. Minus beta 1. You see, we are going to use the beta 1 we got here. Is that okay? So beta 1 is what? 1.3227 times x bar. X bar, no, I think y bar is 35. I miswrote it wrong. So y bar is 35. You can see from here. Y bar is 35. And then x bar is 19. So what is beta naught? So multiply 1.322 by 19, and then 35 minus that answer. I got 9.8681. Did you all get that? Okay. So we have beta naught and beta 1. Now we can write that here. So it means that we are going to have y hat equals our beta naught, which is what? 9.868. Plus our beta 1, 1.3227x. Does that make sense? Then now you can use that same idea to do B. Is that okay? I'll skip B, and so you should try B by yourself, but I would go and do C. Is that okay? So to do C, what is missing? Y bar is missing, SY is missing. Is that okay? But we have this guy here. Is that okay? So when you look at this guy here, what is beta naught? You all agree it's 250. Okay. So let's do C. Let me start C from here. So beta naught is what? 250. Is that okay? What is beta 1? 12. How many of you think it's 12? I don't think it's 12. Negative 12. Does that make sense? It's negative 12. Is that okay? Okay. What is missing? Y bar and SY. Is that okay? So I write here Y bar. I don't know. SY. I don't know. That's what I'm looking for. Is that okay? Now, when I look at the formulas here, I can see that I can use this guy here to find Y bar. Do you agree to that? So let me write that. So I have beta naught equals Y bar minus beta 1 X bar. We already know beta naught to be 250, isn't it? We wrote that here, right? So I have 250 equals Y bar, I don't know, minus beta 1, which is negative 12, times X bar. What is X bar? X bar is 46. Thank you. So I see that a lot of students make mistakes here because of this negative negative. Let me show you how to do it rightly. So we have 250 here equals Y bar. Put this negative here. Is that okay? Now do negative 12 times 46. Do you guys remember what we call PEMDAS? Parenthesis first. Is that okay? Let's do that. So negative 12 times 46. What do you get? Negative 552. Do you see? Now we have 250 equals Y bar. Negative negative becomes plus 552. Do you see that? So now you can see Y bar equals what? 250 minus 552, which is what? Negative 302. So we've seen we find Y bar. The next thing we want to find is SY. SY, we need this guy here to help us find SY. Is that okay? So we have beta 1 equals R SY SX. Okay? What is beta 1? Negative 12. What is R? Negative 0.9. What is SY? We don't know. What is SX? 7.3. Let's double check. Yes. So now you want to use your calculators to do this. Is that okay? I want you to know that if you have 4 divided by 3, it is the same thing as what? 4 times 1 over 3. Right? It is the same thing. Okay? Why did I do that? I did that because so that I could separate this 7.3 from this SY. Is that okay? So it means that this is the same thing as what? Negative 12 times. Negative 12 equals negative 0.9 divided by 7.3 times SY. Is that okay? So now do negative 0.9 divided by 7.3. What do you get? So I got negative 12 equals negative 0.12328 SY. Okay? So now you can see SY equals negative 12 divided by negative 0.12328. What do you get for SY? 97.33. So now let's fill that out. So we got 97.33. And then what did we get here? Negative 302. So this is how to go about it in your worksheet. You can use the same idea to do this too. Kind courtesy, the course coordinator has also provided an Excel sheet. So I want you to open as you learn. You'd see a link which says test 2 Excel sheet. So I want you to open as you learn, and then we will look at that. Have you guys been able to see it on as you learn? Go to week 5. You'd see when you go to week 5, you see copy of this. It's a link. So whenever I create the link, it goes to my Google Drive. So you have to create a copy. So you go to File, and then you hit copy. It gives you a copy in your Google Drive. So you have to do that. So when you open that, it should give you so when you go on Australia and you go to week 5, you'll see it here. So it looks like this. Now you have to be able to create a copy. You can go to File, and then you can do make a copy. Is that okay? And create a copy for yourself in your Google Drive. Now let's try to change tabs. Okay, so to do that, let's look at A. What is A? So you have to be able to know when you have this Excel file here, you have to know where to input your numbers and what you are looking for. Is that okay? So A, you see that you have to input X bar. So the empty spaces in white is where you have to input. So it means that this line here on row 11 on my sheet here, it's computing the intercept and then the slope. That is what I need for A and B. Is that okay? So line 11 is helping you compute the intercept and then the slope. Is that okay? That is what you need for A and then B. Is that okay? So let's verify. Let's input our X bar. What is our X bar? It's 19. What is SX? 6.6. What is our Y bar? 35. What is SY? 9.7. What is our R? 0.9. So you see, our intercept is what? 9.86. Is that okay? And then our slope is 1.322, like we got. Does that make sense? So you can see this is what? Working. Is that okay? So you should be able to have access to this Excel file, and then you can also use to answer your homework problems. You can use the same thing for B, but let's do C. So when we came to C, what was missing in C was we were missing Y bar and an S of Y. Is that okay? So we are missing Y bar and then S of Y. So which of these lines here do you think, tell me the line which you think is better to compute that? So you can see that we are missing what? Y bar and S of Y. So you can see this line here, row 9 would help us because row 9, it's computing S of Y and then Y bar. Can you see that? So it means that let's input our X bar for that, for row 9. So our X bar, we are doing 46, that is C, 46, and then XX is 7.3. We don't know Y bar, we skip. We don't know S of Y, we skip. What is our R? Our R is negative 0.9. What is the intercept? Our intercept is 250. What is the slope? Our slope is negative 12. Do you see? And then you see, then it computes it for you. So 46, 7.3. I don't mind it's not computed. Did you just compute the Y bar? Mine didn't compute. But when I did it, it computed. But let me see. You could also try D. For D, we are missing Y bar and then R. So we are missing Y bar and then R. So it means I want to use line 10 for that. So let's do 21.2. Here is 2. I don't know Y bar. SY is 32.4. I don't know R. The intercept is minus 260. And then the slope is 14. It computes this for you too. And I think you're left with Y bar. Yeah, I don't know why it's not doing, but when I did at home was doing, but yeah. But that is the Excel file that you can also use to compute that. If it's not working, you can also use the mathematics way that we have done. The other thing we want to talk about is the assumptions. So the assumptions is that anytime we want to be able to check a linear, we should check that it's quantitative, there is a linear relationship. In your homework, what they decide to also do is to provide some plots, which is the residual plots. You could see either residuals versus X or residuals versus predicted, either of them. And then they would ask you to check which assumption has been violated, or you should also check whether it's an appropriate linear model. So to do that, I have some of the problems from the textbook, which is similar to your homework problems. So let's try to be able to see how we can answer question 13 and then 27. So let's get to question 13 first. So this is question 13. So when we read question 13, it says that here are residual plots. Is that okay? So it means that they've plotted the residuals. You know what residuals are now, which is what residuals plotted against predicted. So this is what residuals here. And then this is what predicted or fitted value. Is that okay? Good. And we are told these are for three linear models. Now, indicate which conditions appears to be violated. And then they've given you the conditions here. Is that okay? So when you look at this one here, A, which condition do you think is violated? Anybody wants to try? Mm-hmm. So the question is, they're asking you to look at this residual plots here and state which conditions appears to be violated. They've given you the condition, linearity, outlier, and then equal spread. Which of these graphs here violates which condition here? So when you look at the first one here, you can see that it violates the linearity. Is that okay? Because you can see from here. Is that okay? Let's get to the second one. Which condition do you think it violated? Outlier, right? Because of what? This point here. How about this one here? Equal spread. The spread has to be what? Equal. Is that okay? So you can see it has also violated the equal spread. Does that make sense? Now let's get to question 27. So question 27. So it says that tell what each residual plot below indicates about the appropriateness of the linear model that was fit to the data. So what it means is that you should check if the linear model that was fit to the data is appropriate or not. Is that okay? So for example, let's do the easy ones. Here, I could see that what? The model is not appropriate. Can you see that? You can see that what? Why? Because the relationship is what? Non-linear. Is that okay? So here you can see that the model is what? Not appropriate. Is that okay? How about here? Is the model appropriate or not? No. Why? The spread. Is that okay? You can see the spread is what? Changing. It should be equal, but it's looking like a funnel. Can you see that? Good. How about here? Here is what? Appropriate, because you can see the spread is not that perfect, but you can see it's like even. Is that okay? Good. So these are some of the things that is in your homework problems and in your quiz. And so you should be able to know how to go about that. The other thing we want to do is that now we want to go to start crunch and then do a full problem. So to do that, look through your notes. There is this data set, load it into start crunch. So what this data set is trying to show is that it gives the distance flown and then the airlines fares from Atlanta to several US cities. So what it means here is that the distance is the what? Is your explanatory variable. Is that okay? And then the fare is your what? Your response variable. Is that okay? Anytime you are giving data, you should be able to identify your response variable and then your explanatory variable. I told you last Monday and Wednesday that your response is what you are trying to what predict. Is that okay? So try to load this data set and then try to write this problem down. So because when I go to start crunch, I'm not able to come here, so they could be able to what answer them. And you have access to the slides on As You Learn. So try to have that opened. And so if I were you, I'll try to have a divided screen so I could be able to compare. So now I am going to start crunch. So this is start crunch, and then I'm going to load the data. So you come here, then we go to share data sets, no data, load. We go to share data sets. And then I do SRA space ATL. I don't want to type everything, but I know when I enter, then I look at whatever is here and what I have here, and I can see it matches. Is that okay? And I might click on that. Has everybody been able to load the data set? Okay. So now you can see our explanatory variable is the distance, which is in miles. Our y is the response, which is the fare. Is that okay? So now to do this, to be able to answer what is the slope of the line, what is the intercept, what is the equation, all we have to do is to do a linear model. So to do that, we go to stats and then we go to regression. So stats, regression, and then we go to simple linear. It's very important you know what to do with StatCrunch because on your exams, you have it available to you. So you have to be able to know what to do. Is that okay? So I go to stats, then I go to simple linear. And then I click on simple linear. Our X variable, you can see it has been named X. So I click on that one, X here. You see X explanatory, like the heading here. Is that okay? And then the Y variable is the response, which is here. Is that okay? And then I scroll down, scroll, and I choose this one. We should plot the line of best fit. Is that okay? And then when you do that, let us hit compute. When you hit compute, last time when we did this, we didn't care about this. We only cared about the graph. Today, we are going to care about both. So the first question is, what is the slope? So when you have this, you can see this is the slope. Can you see that? So then you write the answer for the slope there. This is the slope. Does that make sense? So this is the slope. And then the next question is, what is the y-intercept? The intercept is this 177.2145. Is that okay? You can also see it here. You see, it's also trying to give you the line here. So you can see it from two sides. The intercept is also here, and then the slope is also here. Is that okay? So now, in your homework, you'll be given some of them. You have the data. You can be able to enter them here, and then you can do this and answer the questions. Is that okay? Good. So now that you have been able to do this, now the next question is that what is the equation of the linear model? The equation of the linear model has even been given to you here, but you have to be able to write it in context with the problem. Is that okay? So we can see from here, we already know that y hat is equal to beta naught plus beta 1 x. Okay? And then in this problem, my y is the fare. Is that okay? So I put in fare. What is my beta? Beta naught is the intercept. It is what? 1772 0.214 plus my beta 1, which is the slope, 0.0786. And then my x is the what? Distance, which is in what? Miles. Is that okay? So what I did is that I know this one here to be the foundation, and then I use this to build based on the problem. Is that okay? Does that make sense? Good. Any questions so far? So that is how to compute, to write the model. The next one is that you want to estimate the fare for a 200-mile flight. To be able to do that, we want to estimate the fare for a 200-mile flight. So we know from our model, we know that fare is equal to 177.214 plus 0.07861 and then distance. So I want to know the fare for a 200-mile flight. So the distance is 200 miles. So I do fare equals 177.214 plus 0.07861. Wherever I see the distance, I put the 200 miles there. Does that make sense? Now use your calculator to tell me the answer. What do you get? Multiply this by 200 and add this to them. What did you get? 192.9. Did you all get that? Okay. So that is how it's very important you know how to do this because StatCrunch asks you to do that. Is that okay? You could also use the homework asks you to do that. You could also use StatCrunch, but you see StatCrunch unless you have the data. But how about on your homework or your exams, you just have this, and then you ask to find the distance for 200 miles. You cannot do that on StatCrunch. Is that okay? So you just need to know how to do this too. I think this is easier for you to do. You just need to plug in and then. But if you have the data set, we could also predict. So let's try to do that using StatCrunch. All you need to do is to go to Options, Edit, and then you can come here, Prediction. Do you see? So X is what? 200. Does that make sense? And then I hit Compute. When you hit Compute, all you have to do, let me open this a bit and then scroll. You see? 192.936. Do you see that? The next one is that we want to predict estimate the fare for a 2,000-mile flight. So try to plug in 2,000 and then I'll do using StatCrunch and see if we'll get the same answer. So I'll just put 2,000 here and then I'll hit enter. And then let me expand this. And so I get 334.45. So that is the fare for a 2,000-mile flight. Is that okay? Based on the model. Any questions so far?